Hi, and welcome back to the Red Car Learning Path. This is Neil Bolger again, and we're going to continue on in the third video about a Tableau introduction with field monitoring data. I wanted to pivot and talk a bit about our second topic of data cleaning and some ideas of why we clean data and some common issues uh, that that we deal with. And then I think I'll pretty quickly move on to Tableau prep. So data cleaning. So the goal of data cleaning. So I would say the first bullet I added here is goal focused cleaning. So what are we trying to do? So I think in my experience of cleaning data, and I will have a lot more to come, I really do think it's important to think about the goal in mind because it may end up being that you need to use a data set to answer many goals. However, one of those goals might make cleaning the data or organizing the data really is the term a lot more time consuming than some of the other goals. So some examples of what could be time consuming and what would not be time consuming. So a lot of, let's say you had a goal where you wanted to look at some data and understand if you had temperature data and power data for a building or even just a fan in a building and a room in a building, the raw data, often you could ask the question of, well, what is the hottest temperature this room got to? Or what was how frequently was it in the top 25% of its peak temperature? Uh, those are almost statistical questions, and those end up being the fastest questions I've found we can answer and really require very little cleaning of the data. We probably need to make sure we don't have any zeros, which can sometimes cause errors in that questioning. I've found that in data, you can have a few types of errors when you start to look at data logs coming from different sources. You can often have blanks where there's just literally missing data. Some systems, though it is less common, will fill in blanks with zeros. And that we will try and find a sample of that. Generally, that occurs when it's very clear that the reading should not be zero based on the type of data and the timestamp. But I would say in trends like these that we're looking at, where this is amps and we see low numbers, I don't know that I would consider a zero to be a bad thing. But zeros can be troublesome because, again, if we were to do that counts as a point, whereas something that is blank, using different data tools, the blanks will not be counted when you do statistical analyses. When you say I want to find the average, it will not average the blank value. So those could be very quick, right? We could do those types of questions and answers very quickly. If we wanted to say, these are both sets of fan coils and they're in amps, and we have data readings for a lot of time. If we wanted to answer the question, well, how much energy did these fan coils use? That's a little bit more of a challenging question. That regards these measurements are in power, or amps is a unit of power, and it does have time. But now it's very important to understand, like, well, what is the time step we have? This data has 1 minute time step. So technically, if we were to add up the energy used every row, each row only counts as 1/60th of an hour, 1 minute. And so we would need to put that in. We couldn't just sum all of this up. We would we'd be adding up power, and we'd be assuming that each one of these, if we just assumed they, was agnostic of time. And so it becomes more challenging if we were to try and say, well, I have this fan coil I want to know the energy on, and then I have another set of data, let's say, that is other fan coils, and that I also want to add the energy up, and the time step is maybe every 15 minutes. We would need to normalize for time. And so that becomes a big part of the cleaning process. Time normalization is probably one of the largest things we'll end up troubleshooting, and the skills we'll be focusing on the most. The next biggest one I think would be identifying data gaps and also considering like how to reconcile, what to do about those. So energy is probably the challenge. It's probably the biggest challenge in cleaning data. That's the second biggest. The third, let's see if we look at another set of data. So this is over here is a fan coil with some power. Though in the same building, just as a demonstration, I'm going to open up another set of data that we took from the same time period. So this is a conference room in the building. It has temperature and carbon dioxide. So another thing we often need to do, or other questions we may ask, would be questions about if we know that the sensors and readings in a building were during the same time and have some relevance to their locations. And an example I'll give is, let's assume that these temperature and humidity sensors were in the same room as this fan coil. We could actually ask the question, well, when the temperature in the room was above a certain threshold, let's say when it was above 75 degrees, so right here when it went into 75 degrees, what was the power demand of the fan coils? And so what we're asking is basically now to plot, temperature versus power. And these two CSV files, while they do have time as their common denominator, it is not as easy as you would think to establish a whole matrix of data. We're basically now making a large matrix where we can ask questions across the data. Generally speaking, most building end-use metering systems will just keep one data set with its own timestamp and will not quickly be able to compare a data stamp to another data stamp independent of time. Maybe you can in a BMS, but a lot of our data, if we were to just put these together in a very, very large database, the default way would just be to stack time on top of itself. And so you would end up with a lot of data that did occur at the same timestamp, but isn't necessarily in a flat matrix where we can compare across the data. We would need to, I would say, first normalize time and then align the data such that there are common headers for each string of data, and then the data itself, if the timestamp wasn't equal, we would either have a lot of gaps when we had data in one and no data in the other, or we would need to make a choice. Often a choice might be, we have 1 minute data here, but we would need to average or normalize the data to the smallest timestamp of our final matrix. And I'll say that again, or I'll demonstrate what that could look like. Let me see if I have another set. So if this data is also in 1 minute. So some data sets, there are points, I don't know if I have them in my set here, but it is very common to find that we have 1 minute data stamps as well as, say, 15-minute data stamps. And so 15 minutes would now become our limiting factor. We would basically need to say, well, if I want to be able to, let's assume this fan coil power was 15-minute data. If I wanted to know the temperature, my recommendation at that point would be to average the 15 minutes of data we have here into one point and then use that to compare against the power reading we have here. And so that all of that effort to normalize or to average data, to fix time, to combine them together, those steps will lose data quality. Some of the data in this example, the temperature data the quality would be lost because we'd be compressing all this data into one point. But the point of that database would be to make a comparison. It would be temperature versus power. And so that might be a valuable answer we need to understand about how this system and building works. However, that data set, we may want to make that a unique data set just to answer that question. I'm definitely a fan of being clear and transparent in what we're doing, though, and you don't want to necessarily end up with too many offshoots of the data. However, if we do need to answer questions about power, frequency above a threshold, things that are more statistically based, the raw data itself is the statistically most accurate place to go. If we need to answer questions against data, one versus the other, the only way to really do that is this 15-minute averaging. And if we just want to review the trends, sometimes stacking time over time and just putting this data right below this data and then looking at it all together, you would not be able to cross-reference them, but that is the smallest file size you will often find for a database, is just to have time repeat. Whenever a data point appeared at 1042, there's another row for 1042. That ends up being a very, very small file. So if our goal is to just visually review the data, that's a lightweight way to go. So I just say this so you can start to think about, what is the goal I'm trying to answer in cleaning my data? And you may find that if you have multiple goals, which is very common, it might be best to start with one of the simpler ones, and then make a plan on how to outline one of the more complicated ones. I've found that trying to make a single clean data set that answers all your questions may actually end up being more work and create problems. So if you tried to only clean all the data to be 15-minute averages with no gaps, and then organized it, it may then be troublesome when you start to ask questions about statistics of the data. When was the peak value? What was the trough value? Because you're now basing those questions on a averaged data set. And that actually may then create issues, because you would have to think about, well, how do I explain the statistical significance of what we've now done? So you may end up needing two data sets sometimes. You may need one that's more the average to answer annual questions or comparative questions, and you may need one that's more the raw but clean and organized flat data to answer statistical questions. So that's about it. The common tools at our disposal, we do use Tableau that we're going to look at. We'll talk about Tableau Prep, which is a great tool for cleaning some data. Excel is by far one of the most powerful tools. I would even say Visual Basic inside Tableau, or inside Excel, is a great tool for lightweight programming to potentially fill gaps. Sometimes filling gaps, for instance, this is probably a good example. Some things we'll go over. If there is gaps in data, such as these, where it's pretty clear that this data would have been the same power data, we'll go over some ideas about how to fill this in with the average of the prior and post number. And so those types of codes to fill in the blanks probably should actually be written in Python, or they could be put in Excel, but Python ends up being the tool of choice when we actually start to think about doing batch cleaning of multiple files that may have the same challenge. So with that, that's a little bit of what is data cleaning? That's kind of the process. It's no perfect. There's no one way to do it. But with that, I'm going to go over a little bit of Tableau Prep, and we're going to talk a little bit more about what we can do with that software.